Okay, so we're going to be solving trig equations this time. This comes on quite nicely from the last one where we were looking at identities, because you'll need to use some identities to solve some of these. Now, not all of them, just some of them, just to let you know. So, the first one we're going to do is cot squared theta minus 3 cot theta equals minus 2. Now, if you notice, you have a squared, a not squared, and no cot at all. Now what we're going to do, make it into the form of a quadratic, so that definitely says cot, not cat. Minus 3 cot theta plus 2 is equal to 0. Then, if we were to pretend that cot was x, we could then factorize this into two brackets, and to get minus 2 and minus 3, we're going to have minus 1, we're going to have minus 2, we're going to have cot theta as our x, and cot theta. If you multiply that out, cot squared minus 1 minus 2 is minus 3 plus 2, which means that cot theta is equal to 1 and 2, which means that tan theta, because remember, we can't really type that into our calculator, tan theta is equal to 1 and a half. Okay, now we have our values for tan. If you type into your calculator tan to the minus 1 of 1, and then you type into your calculator a half, you will get, I will just rub this out, you will get tan theta, or just even theta because you've used tan already. You're working out what theta is. When you type tan to the minus 1, you get theta is equal to pi over 4, which is approximately 0.78, I think. That's the 2. And you will also get 0.464. Now, by the way, we are working this out where 0 is less than theta, is less than or equal to 2 pi. Okay. Now we have this, we're going to go into the quadrant diagram or cast diagram, however you want to call it. It doesn't matter. So, write that in. This is 0, 2 pi. I sometimes write the symbol for 2 pi, but that's not important. Right now, if you want to know what it is that tau just means 2 pi. That's the quicker way of writing it. So, in this, we're looking at where tan theta is going to equal pi over 4. Now, pi over 4 is 45 degrees, so that's going to be here and here. Then, for 0.464, that is actually a little bit less than pi over 4. And this is also where tan is positive. So it's going to be then in here and in here. Then if you work around going to this angle, then the whole way around to this angle and this angle, that is going to work out as theta is equal to 0.464, that is that one there, pi over 4, which is that one. Then if you go all the way around past pi, so past 180 degrees, we get 3.606, and we also get 5 pi over 4 as that last one. These are all in radians. You can put a little c after them. Just that's like the degrees symbol. Instead of putting a circle, put a wee c. It means radians. You don't have to. You can just write radians after it. But that's how I like to write that. Okay, this next type I find really satisfying. So 3 cos theta plus, now the question says 4 sec theta. I would like to write that as 4 over cos theta, because sec and 1 over cos are the same thing, equals 8. Now remember, we can minus 8 equals 0. 3 cos theta is still here. Okay, now because this is that's kind of on the bottom, we can multiply everything by cos theta and get our quadratic that we like to see. So plus 4 minus 8 cos theta is equal to 0. Now you could, move that back around to get the normal squared, not, but it doesn't really matter. It's still in the correct form. We can factorize this. The terms may not be in the correct order, but that's okay. So let me remember, it's going to be 3 cos theta minus 2, and cos theta minus 2. Yes, because then it's going to be minus 6. Minus 6. That's going to be minus 2, which is going to give minus 8. And then that is going to be plus 4. That's going to be 3. Good. Then we get 3 cos theta is equal to, well, that's going to be 2. And then cos theta equals 2/3. And we're also going to get cos theta is equal to 2. However, that doesn't exist because remember, the cos graph, it kind of looks kind of like that. That there is 1, and 2 is up here, and there's no value up there, so that you can literally just cross out because that does not exist. So we are left with cos theta is 2/3. Cos theta is 2/3. Theta, or cos to the minus 1 of 2/3 equals, I'm in degrees now, by the way, 48.19. So yes, this is going to be, and my lights went out. Great. This is going to be 0 is less than or equal to theta is less than or equal to 360 degrees. Just to let you know. Now, next step is always draw your diagram. Now remember, we're going 0 to 360, and this is going to be 180. These are the only ones I read in because you kind of remember it from there. We are looking at 48.19 degrees, and this is where cos is positive for these two. And then, if you go up to there, and you go the whole way around to there, obviously that's the whole way around from the start, you're going to get theta is equal to 48.19 degrees, and also 311.81 degrees. And the last one is going to be 3 tan squared theta plus 5 equals 7 sec theta. Now, we see a sec and we see a tan, and we know that those two do not, work as a quadratic, but we do know that tan and sec have a relationship. Tan squared theta is equal to sec squared theta minus 1. Remember from our things, so what I like to do is I remember sine squared theta plus cos squared theta equals 1. If we divide this by cos squared, we are going to get sine of cos tan squared plus 1 is equal to sec squared theta, and then sec squared theta minus 1 is tan squared. Remember, you can just write that out. So we're going to say that 3 upon tan squared theta. Nope, that was the thing that we were trying to get rid of in the first place. Well done me for just rewriting that. In our bracket we're going to put sec squared theta minus 1 plus 5 equals 7 sec theta. Then multiply this bracket out. 3 sec squared theta minus 3 plus 5 is going to be plus 2. Then obviously minus 7 sec theta is equal to 0. Okay, here we have our quadratic. Whenever you solve this, you get 3 sec theta, and that is going to be minus 1, and you get sec theta plus 2. That's factorising that. You can see that's going to be, there's our, let me see, used to be a minus because there's no way you can get a plus. Minus times minus is plus 2, and that's minus 6, minus 7, 3. So that means that sec theta is equal to 1/3, and theta equals 2. So then we say that cos theta is equal to 3, and cos theta is equal to 1/2. This does not exist because it is greater than 1. We saw in the last example that that doesn't exist because of the graph. And so we're left with 1/2. So theta is equal to pi over 3. Remember, this question's in radians. I always forget to write these out. Yep, it's in radians. So it's equal to pi over 3. Now, let's draw out our diagram. Remember, this is 2 pi and 0, this is pi here. Pi over 3, where cos is positive, 60 degrees. So it's kind of like that. Always greater than, not less than. So it would be plus or minus pi over 3, but then add 2 pi to that. So you get theta is equal to pi over 3 and 5 pi over 3. And that is your answer. Okay, this last type of question can be quite confusing. It's one of those, if this is this, and this is this, then what is this? So, if sine theta is equal to 12 over 13, and theta is obtuse, find the value of cot theta. Okay, well, what on earth does this even mean? So, sine theta is 12 over 13. Well, let's draw a triangle. Sine theta, so sine theta is equal to O over H. So sine theta is equal to 12 over 13. From triangles, we know that this has to be a 5 because 5 squared plus 12 squared is 13 squared. You can work that out in your calculator, it's just Pythagoras. And theta is obtuse. Okay, so that was a really bad grid, but you get the gist. It's obtuse. So it's not here, that would be acute. It's obtuse. It is in this quadrant here. Now, something to note is that here, in this quadrant here, so let's draw a thing. Sine theta is positive. Tan theta is negative. And cos theta is negative. We know this because in this one, that's all of them. In this one, it's sine, that one's tan, and that one's cos. They all get their turn at being positive. That's how you know where to put things whenever you're solving your equation like we did earlier. You know, if it's positive, you put it in the all, and you put it in the positive one. Or if it's negative, you put it in the other two. We know that because it's obtuse, it's here. That means sine is positive, tan is negative, and cos is negative. So we are asked to find what cot is. Well, we know that cot is 1 over tan, so let's see what tan theta is. Tan theta equals O over A. Tan theta is equal to O, that's 12, over A, which is 5. But if we look over here, tan is negative because the angle is that big. So we will just put a minus in front of that. As simple as that, because we know that tan is not positive, the answer is going to be a negative number. And so to get cot, let me just rub this out here. To get cot is equal to 1 over tan theta, which is equal to 1 over minus 12 over 5, which is equal to 5 over 12. And it's negative, and that is what cot theta is equal to. If it also asked you, for example, what cos theta was, cos theta is equal to A over H. Cos theta is equal to, remember, cos is negative, and A over H, that's going to be 5 over 13.